Okay, so we are going to solve this general solution using variation of parameters. So we have to find yc and yp, and yp we're going to use generation of parameters to solve for it. So yc, so let's first rewrite the equation again. We're going to divide by 4, so we have y prime plus 36 over 4, which is 9, equals 1 over 4 cosecant 3x. Now, so pretty much we're going to set y to be equal to m. This is m squared plus 9. Okay, and we're going to set that to be equal to 0. Now we isolate for m. So m1 will be the square root of 9i, which is just 3i, and m2 will be minus 3i. So m1, m2, it's plus minus 3i. So when we have imaginary numbers, yc is equal to c1 times cos the imaginary component, which is 3x, plus c2 times sine 3x, and all of that to the power of the real component times x. So the real component here is 0 times x, so it's just 1. So that's yc done. So from yc, we're going to go to y1 and y2. So y1 will just be this portion, y2 will be this portion. And now we're going to use this to solve for yp. So we're going to do generation of parameters. So we have w, which is a matrix, and inside the matrix is y1, y2, the derivative of y1 and the derivative of y2, and it's equal to, we have to get the determinant from here. So let's find y1 and y2. So we already know what that is. And then the respective derivatives, they're minus 3 sine 3x, 3 cos 3x. Their determinant should be 3 cos squared x plus 3 sine squared x. And if we factor out the 3, this whole thing is just 1. Now let's do the w1. So this will be the left. So the top left side is just 0, and the bottom left is our output, which is 1 over 4 cosecant 3x. And then on the right side, it's just this portion. Okay, this will be just 0 minus 1 over 4 cosecant 3x times sine 3x. So cosecant 3x is just 1 over sine 3x, so that means these two cancel each other out. So we just have minus 1 over 4. So now w2, the left side, it just includes this portion. And the right side, it's just this portion. So it's just 1 over 4 cosecant 3x times cos 3x minus 0. And this, recall, this is just 1 over sine 3x. And cos over sine, that's just cotangent. So it'll just be cotangent 3x. Okay, so now we have to find u1 and u2. Okay, so u1 and u2, that's u1 is equal to the integral of w1 over w, and u2 is equal to the integral of w2 over w. Okay, with respect to x. So this one, it's going to be the integral of minus 1 over 4 all over 3 dx, which is equal to minus 1 over 12x. So that's your u1. We're taking the constant to be 0. And this one, it's going to be the integral of 1 over 4 cotangent 3x all over 3 with respect to x. And this let's do this part first. So that's just 1 over 12. Okay, and we have the integral of cotangent 3x with respect to x, or dx, sorry. So the integral of this will just be 1 over 3 ln of sine 3x. Okay, the reason for this is because if we were to differentiate this, so 1 over 3 times 1 over sine 3x times the derivative of this, which will be 3 cos 3x. This cancels out, and this part is just cot 3x. And this whole thing is pretty much just 1 over 36 ln of all of that. Now we have u1 and u2, so our yp will be u1 times y1 plus u2 times y2. So it'll be minus 1 over 12x times y1, which was cos 3x, plus u2, which is 1 over 36 ln of sine 3x times y2, which was sine 3x. And that's your yp. And then to get your y, you just add your yp and yc. So add this up here and then add it to yp.